Hi guys, welcome to my presentation for the Autodesk Advanced Manufacturing Summit 2020. My name is Janne Kitanen, and today I will be talking about one of my dearest topics, 3D TI, 3D thermal form injection. Now, I have been in the 3D printing industry for a long time, maybe 25 years give or take, but I've always struggled to find this mega super scalable application that will spin people's heads around and also help them understand that the solutions don't have to be so complicated. And you know what, guys? This is it. But also bear in mind that the presentation might be so wild that, and also hence the reason why I'm doing it in the car, then you actually might want to buckle up.
3D TI, merging the best of 3D printing and packing technology for breakthrough manufacturing solutions. After spending the last 25 years within the 3D printing industry, I've come to realize that the most scalable applications are actually quite simple. I will be talking about 3D TI in this presentation, and I will demonstrate for you how to create the most scalable and the most profitable applications with 3D printing. Yes, you heard it right. The most scalable and the most profitable applications. But before we start talking about 3D TI, let's chat a little bit about disruption and what are we actually disrupting. Now, I see these kinds of media stories a lot everywhere, from CNBC to CNN to Whatnot News Network. And my key question here is, what are we actually disrupting? What are we actually disrupting? So all these news stories tell a story about how 3D printing is going to transform the 12 trillion manufacturing industry and fueling the fourth industrial revolution on its path. But let's dive a little bit into the history of everything and look into the 3D printing industry growth metrics and how things are actually being tracked. So the fundamentals of the 3D printing industry's success and growth is measured in machine sales and software sales and material sales and all the technical and technological aspects that come within this particular industry. And if you look at this graph, it looks great, 20-30% growth every year for the last 35 years. But if you indeed want to disrupt that 12 trillion manufacturing sector, it would take quite a bit of time. You would need probably a few millennia in order to come to, those kinds of numbers. So, and in order to fully demonstrate this, I wanted to dissect one industry and give you a kind of a background information. What does that mean if we're talking about, let's say, hardware and machine sales, and what kind of numbers are we talking about? And of course, there's a lot of progress and a lot of media articles also about footwear and how 3D printing might, again, disrupt a 400 billion global market. But in order to demonstrate what it means when the success is measured in selling technology rather than selling the end product. So with these couple of slides, I'll be demonstrating what does that mean. So on the left, you have the footwear global sales pie, 400 billion market, which boils down to about estimated 24 billion shoes per year. But if people are talking about disrupting the footwear industry with 3D printing, then on the right, you will kind of see what it boils down to. So I'll just make this graph focusing on the BOM market, which is coming together from the materials and labor and overhead and machines. Pretty much that pricing trajectory when it leaves a port, let's say, for example, in Shanghai and goes to the Western world. So it is estimated that the machines create a very small, only $1.5 billion industry within the footwear manufacturing world. And also bear in mind that these companies do not even buy machines every year, nor would they upgrade an existing machine also every year. If you look at footwear, the way that things have been manufactured for decades, I mean, a lot of the core technologies have not changed for a long, long time. So most factories still make the shoes in a very same way as they made several decades ago. So what would it mean for the 3D printing industry if it were to disrupt not the 400 billion market here, but let's say the 1.5 billion dollar market? Let's say we're very positive about the penetration of 3D printers into this industry. I would guess, let's say just 1% of the entire footwear machine sales market, and then you kind of in a ballpark of 150 million industry out of a 400 billion global footwear marketplace. So again, the machines themselves are many times a very, very small portion of an entire industry, and where the end products are the ones that are creating the most value for the user. And at the end of the day, then nobody cares how things are made. They just care about what kind of product are they getting in their hand, and what kind of value that is going to create for them or for their lives. Well, if the money is not in the machines, then how disruptive are parts? You see all these kinds of media stories out there as well, that we're able to optimize parts to make them lighter. We're able to consolidate parts instead of being multiple 5, 6, 7 assembly parts. You can make that into one piece. So that is all great, but you need to remember that incremental value within a part, within an industry, will not create exponential opportunity. It will create incremental opportunities. And this particular example may be the engineer's dream, but modifying or optimizing a part is a mere incremental improvement in a bigger scheme of things. And also one thing to bear in mind, when incremental improvement is created, but with a higher cost, most companies' accounting systems are not created to support such innovation. These companies are looking at the world in a very linear fashion, and even if your part is 20-30% lighter, it will increase your efficiency in your supply chain, your inventory, your purchasing, and all that. Even if from an outset it might look phenomenal, but these systems in many companies are not connected in a way that one part would then add value for all these different departments. So many times these kinds of projects they get killed by just the purchasing, who has to prove that every aspect of the part is better, cheaper, and all that. And many times 3D printing, unfortunately, is more expensive as a line item, and then these projects remain nice to have. Here is an example of a solution which is not selling technology. They are selling smiles. And everything in this path to get to this final product is created from scratch, from the manufacturing to the software, to the scanning of the teeth at the dentist, to the sales channels, to distribution and beyond. It is incredibly interesting use of 3D printing, but it is not the means to an end. They are creating tools for 3D printing. They're not creating 3D printed products as the end result. And you see these kinds of examples on every 3D printing fair, and everybody's desk on their booth. You see different examples for the dental industry. But if you look at the amount of material that is being consumed for this particular application, it is with these guys, it is only 5 pallets of 3D printing material per day. So again, only 5 pallets of 3D printing material per day, whilst they're generating revenue of 1.3 billion per year. So again, the comparison between the end product and the value they're creating and the amount of money they're being able to charge for the end user is astronomically higher than for the parties who are making the machinery, making the software, and making the materials. And there will be a second conclusion coming after this, but this is the first conclusion about the history pretty much, and where we came to me talking about 3D TI today. But the biggest impact of 3D printing and the biggest upside for 3D printing is not in what the sales are going to be coming from the machines or material software, but what the technology delivers. So again, the biggest upside for 3D printing is in what the technology delivers, not the machines, not the materials, nor it is the software. We had a 10-minute introduction to a 3D TI. Prior to, I'm going to start my presentation. And ironically, 3D TI works very similar to Invisalign, but now kind of for everything else. So imagine if we were able to merge 3D printing and packaging technology to bridge the gap between 3D print customization and mono-product mass production. And we would be able to do it faster, cheaper, and in more materials than traditional high-volume manufacturing technologies can offer today. May seem impossible, and many of you might think I'm smoking something, but the goal really with 3D TI has been to beat mass manufacturing industries and disrupt entire industries. And at the same time, and again, just as a nice bonus, we're able to customize the production batches from 1 to 100 to 100,000 to a million. For us, it doesn't really matter. It will offer them both customization and full scalability. And next in line, I will show you a video. Technically, everything works for our first application, which is in the frozen confections industry. So enjoy the 1-minute video to show exactly how the technology works. TI addresses the gap in the market, which is economical, high-velocity batch manufacturing. By combining packaging and molding in the same product, our process eliminates terms such as mold opening times, packaging or labeling, which traditionally happen at separate assembly lines after a product has been produced. So again, if you look at it from the perspective of 3D printing, there's a lot of talk about, for example, the term end-to-end products or digital workflows and stuff like that. But many times they are talking about the entire process chain of how to get a file automated into the 3D printer and getting it automatically somehow cleared and quality controlled and checked and all that when it comes out of the 3D printer. So 3D TI goes a few steps further from that. So these products also come fully labeled in their own packaging from the assembly line. And for us, when it comes down to what kinds of materials we can utilize, for us it doesn't really matter. We can use any liquid, paste, or gel-like substance, whether it's tomato soup or toothpaste or popsicles. It doesn't really matter, but we have a few different vertical focus points where we're starting off with, and frozen confections just happen to be the first one. And here's a reason why. If you compare the traditional way of making these kinds of products and to the way that we're doing them, we have done a number of different things here which dramatically change the way these products have been made. made. So for the ones who've been in an ice cream factory before, you will come to realize how gigantic these plants are, and what kind of it's kind of like walking into Starship Enterprise kind of a setting. We have dramatically shrunk down everything, but at the same time, we can still reach the same speeds as the traditional way of doing that is. But again, as a nice bonus, we can make any shape and doing for the fraction of the cost than existing technologies. Here's another example of how you were to compare our technology. So normally, the way popsicles are manufactured, they're manufactured on a kind of a vertical, either a conveyor belt or a rotating system. We have either hundreds or tens, depending on the size of the machine. But let's say there's hundreds of steel molds in the machine. So anybody can kind of do their wild guess how much it costs to change these tools, and how much time and effort it takes to put an entire factory on hold in order for you to do that, and what kind of costs are being involved, and how eager these companies who have their factories already operational. Imagine you go there and, hey, listen, I want to make 100 of these new shapes of popsicles. They're not going to be very happy putting their factory on hold. So here again, if you were to change the steel tooling, let's give or take, put 100,000 price tag on that, all those tools, and if you compare it to our $20 investment on a plastic tool, it's rather different. I also many times do not see very clear data on 3D printing applications. At least I don't. When I see new kinds of applications coming out, and I always ask people, so what was the price? And many times I don't get any response on the social media posts, which kind of gives me an idea that many times these are done for marketing purposes. So I wanted to be 100% transparent and show you what it boils down to when you creating a plant like a 3D TI frozen confection plant. When comparing to traditional way of doing that, we have done the math all the way from sewage costs to electricity to the manpower, to cleaning, to throughput, and so forth. So here's a graph that will show you how you would do it with us if we were to make it in the same speed and same kind of throughput that an existing industrial plant would do it. So you can take a moment and study this for a little bit. Very transparent. And another thing which I also wanted to point down here is that every product vertical has their own pricing elasticity. I have never been a big believer in, hey, we've got this new 3D product, we can make it so fancy and custom and special and all that, but the consumer is not going to pay 20 euros for a custom popsicle. They will want to pay the exact same amount of money as they've been paying for the normal popsicle they would buy in a grocery store. But the consumer is getting smarter by the day, and the new kids on the block, they will just want to have a more tailored solution as there was before, but they want to be paying the exact same amount. I titled this slide New Paradigm in Customization. And let's pause here for a moment and look at those numbers. With 3D TI, we're not just disrupting old industries, but we're also disrupting the entire product development path to an end product. So again, if I were to want to make a custom product for, I don't know, let's pick a Disney theme park here, for example. It's incredibly difficult for these massive companies to do that, and it's very costly. It will take a long time. Those numbers are now totally different with 3D TI, and on top, we're able to add a very three-dimensional customization that has not been possible up until today. And here's our conclusion number 2 from 3D TI. Yes, we are able to beat mass manufacturing with 3D TI, and yet we are able to provide any tailored solution as a bonus. The next slides will show some examples of the work we have done, and for what kinds of brands, what kind of new channels we have created. And those of you who don't know the frozen confection industry, if you look at the way that the popsicles was invented 1905, they're still selling the same shape in the store. So ironically, nothing really has changed over 100 years. And that has also been one of the reasons for us to look at industries which have not been touched by the 21st century digital era, and how could we rethink how these kinds of products are being made. And again, everything has been made in vertical molds until now, and we have literally just changed the entire process, becoming a horizontal process, and we're injecting directly inside the packaging of the product, which is also inherently the mold of the product. Here's some more examples of baseball teams, zoos, corporate gifting, large companies, and so forth that we have worked with and created pilots for in the last couple of years. And here also is a good example of our progress. And also in my earlier slides, I was mentioning that a digital workflow or end-to-end product in the 3D printing industry is rather different than what we're doing. We're literally diving deep into how to create a factory, and every pipe and electrical socket and regulation and walking path inside the plant. How does that entire thing operate? And 3D printing many times is a very small part of it. It is an engine within the bigger factory in a very similar way as Aligntech does with their Visalign, but it is not the means to an end. It is a tool. And again, so we have created by now 4 different factories, 2 in America, 2 in Europe. So we're well on our way with our first application to make this into a big success, and we're on our journey stepping into the new applications that I'll be also demonstrating later during this year, from footwear to soap and beyond. Now, ice cream is great, but what else can it do? Most people in the 3D printing industry don't really understand why on earth are we busy with ice cream. And I can only imagine that since 3D TI is not a technical project, but it is rather a project that aims to disrupt entire industries. So it's a little bit more difficult to grasp than doing an incremental improvement in a particular vertical. The key for using 3D printing for manufacturing in the most profitable and effective way is truly to understand how all these different industries operate. When one does understand how they operate, one can then embark on a journey of creating entire new types of markets, like Aligntech has done with their Visalign product. But again, it's not all roses, so note of caution here as well. It took them also many pivots to understanding how to get there. So creating brands, creating factories, and doing it yourself is incredibly expensive by itself too. But I've always been on the opinion that if you're trying to create something different, try to create something crazy, try to create something big. Because I always use this analogy of, for example, creating a restaurant. No offense for people starting their corner restaurant, but at the same time, if your goal is to make a restaurant of, let's say, 20 seats or 30 seats or 40 seats, your revenue is already capped. You can only have X amount of servings per day. So it's very difficult to all of a sudden make a $1 billion business out of a corner cafe when you only have 30 seats, for example. So that's what I mean by thinking exponential and getting away from incremental mindset. Here are some addressable market opportunities in various other industries. And this is, again, it is just the market size. So note of caution, it is not our goal to, or even try to tell people that, okay, we will capture, 5% or 10% of the bakery industry. Absolutely not. We're there to create new industries and, sales channels, manufacturing plants, all of that. So many times it's a very, very painful and long journey. But at least we have these big industries behind us where we will be able to carve different niches from the ice cream world to the bakery world, to chocolate, to footwear, to all kinds of silicone parts, polymer foams, and so forth. So there's a lot of different opportunities for us in the horizon. And another thing which I wanted to mention is that we're by far not experts in any of these fields. We're also not experts in the frozen confection category, and we don't want to go through that painful process or journey again. So we would love to collaborate with parties who are already masters in these different industries, and they have a foothold in perhaps a sales channel Perhaps they have a brand. Perhaps they have a new channel that we haven't not even thought about. So we're very open to collaborating. And then here are just a couple of examples where we know through our key IP and our patents that the certain innovations are also be very, very interesting, just purely from a packaging industry, from aluminum casting, also metal casting industry, foam industries, ceramics, soap, footwear, and so forth. And I would love to end my presentation with this one-liner. But before I go there, I wanted to give a little bit more background on why I got into 3D printing and why I also fell in love with it, and also why I've been ever since trying to find a different path for me in this industry and how to find those most scalable and profitable applications. I really fell in love with the complexity that 3D printing can offer, and of course that is the heritage of all my artwork, from creating the most complex dresses and furniture pieces and lighting and footwear and eyewear and you name it. But the older I've gotten, I have always wanted to actually swim the other way. And instead of finding the complexity, the beauty in the complexity, I want to find the beauty in the simplicity. And many times people who, again, if you pause there for 1 minute, finding the results in the simplicity and not in the complexity. Again, many engineers say that complexity in 3D printing is free. If from an engineer's perspective, maybe complexity can be free because you can rotate that complex product on your screen in the same velocity as you can rotate the simple product, and you can 3D print it pretty much at the same time. But from a market perspective, it is a myth. Again, reducing assembly and parts, which inherently should result in a simplified quality control and reduced procurement hassle, may seem like a no-brainer, but also need to understand that this innovation created challenges in the entire systems of how these big companies have been operating for many, many years. So even if your product created all these benefits, but with a higher cost, reducing complexity on the parts, just created a headache on the other side for somebody doing the purchasing. Thus, in order for it to create a bigger impact, you need to be cheaper, and 3D TI does just this. So 3D printing is great for making complex and expensive parts slowly, and 3D TI is great for making simple and inexpensive parts fast. I hope I have inspired you with my presentation, and I hope 3D TI has given you some inspiration on how to look at 3D printing as a whole. And again, as I mentioned previously in my presentation, we're very open for collaboration. And by all means, if you have ideas for 3D TI, we're not the only ones with the ideas. We love to collaborate. So let's get in touch and make magic together with 3D TI.